Hello everybody, and welcome to part 1 of our video series on the parabola. So we're going to start by taking a look at the geometric definition of the parabola. And through this definition we'll be able to understand how we get the equation of the parabola, as well as have a better understanding of how to properly graph and interpret the graphs of the parabola. So as we go through this definition, we'll go ahead and take a look at this picture down here to relate it to what we're describing in the definition. So let L be a line, that's this black line down here, and F be a point not on the line L, so that's this point up here. Then the set of all points P in the plane that are the same distance from F as they are from L is called a parabola. So if we look at our red graph of the parabola here, what makes this a parabola is that every point on this graph, such as this point P, if you draw a straight line to F and you draw a perpendicular line down to L, those distances will always be the same, no matter which point on this graph you pick. So, in other words, a parabola is the set of all points P for which the distance between F and P is equal to the distance between P and L. And that specifically is where the distance between P and L is the perpendicular distance. So we're going to go ahead and name the various parts of this graph so that we can refer to them a little more clearly. So we call this line L the directrix. We call F the focus. So you could kind of think of these names as the directrix kind of directs how the graph moves out, and the focus pulls the graph in around it. The line MF that passes through the vertex and is perpendicular to the directrix is called the axis of symmetry of the parabola. So that's this line here, and it's called that because on either side of that line, your parabola looks like a mirror image. The point at which the axis passes through the parabola is called the vertex. So that's V here. So let's note that the vertex of the parabola is the midpoint of this axis of symmetry here, MF. And we will denote the distance between V and F here, and likewise M and V, as P. So that is to say, this distance between the vertex and the focus, we're going to call that P. And similarly, this distance between M and V, we're going to call P as well. Right, they're the same distance, and we'll refer to that as P in our equations for the remainder of this topic. Okay, so how do we find the equation or formula for the parabola? Well, we're going to start by considering the simple case where the vertex is at the origin, that's 0, 0. And the directrix is a vertical line, x equal to negative p. So we've drawn that as this blue dashed line here, and the vertex is our black dot at the center, and this red graph is our parabola. Now, what we know is that the distance between P and F, and P and the point on the directrix that's perpendicular to P, those distances are going to be equal. So if we look at this point A, we were able to determine what the values for the x and y coordinates would be. Since this point is on the directrix, the x coordinate is negative p, and the y coordinate is the same as the point P, since the point P is perpendicular here. So all we have to do is use our equations for distance, or I should say our formulas for distance, to build an equation relating these two things. And keep in mind our focus, since it is a distance of p away from the vertex, that puts the focus at p0. Okay, so we're just going to plug into our distance formula. So here we've got x minus p squared plus y minus 0 squared. Of course, we don't have to write the 0, but this is the distance between p and f, so let's make sure that makes sense. We've got our x coordinate, x minus p, and our y coordinates, y minus 0. So that's the square root of x minus p squared plus y squared. For the distance between p and a, we're going to look at, well, we've got x minus, oops, did not mean to erase that. We've got x minus negative p, which is x plus p, and y minus y. So if we simplify this slightly, y minus y is of course 0, and we get this equation. The square root of x minus p squared plus y squared equals the square root of x plus p squared. By squaring both sides of the equation, we get rid of our square roots. And now when we take these binomials and multiply them out, we get the following. X squared minus 2px plus p squared plus y squared on the left-hand side, and x squared plus 2px plus p squared. Now we see that the p squareds cancel, the x squareds cancel, and when I take my negative 2px and add it to the other side, I end up with y squared equals 4 times p times x. And remember, this p is very specifically that distance between the vertex and the focus, or likewise the distance between the vertex and the directrix. Now we could take this same idea and find a various set of equations or formulas for the parabola. But this specific one is called the standard equation of a parabola with vertex 0, 0 and focus p0. That's y squared equals 4px. So we have here a set of 4 different equations of the parabola and the various properties that can be described by those equations. Now, personally, I think that these charts are not incredibly helpful. I think that what is far more helpful is to understand geometrically how the parts of the parabola relate, and then understand how that relates to the formulation of the equation. Memorizing a chart like this is not super practical. However, it's always good to have a reference to check when you're first starting out. So what you may want to do is pause here and take a look at this chart and maybe copy it down into your notes. But I'm going to focus on the graphs and how they relate to the equations so that we can formulate these things in a way that's much easier to conceptualize and I think will stick with you more effectively. Okay, so let's take a look here at this graph on the left. So this is the same graph we started with that we derived explicitly. And we've got our distance here between v and f is p. So of course f occurs at the point p0. And since we're going a distance of p backwards from the vertex, our directrix is at x equals negative p. That gives us y squared equals 4px. So whenever we have an equation that's facing right or left, it's going to be a y squared type equation. Now, when our equation is facing right, we're going to have just a positive term in front of our 4. Right? That's just positive 4px. Now, if we take a look at this graph to the right here, it's similar, but it's flipped around. Our vertex is still at 0, 0. And our distance, as always, between the focus and the vertex is p, but that puts this focus at negative p0. And it puts this directrix at x equals p. So in this case, we get the same basic equation, y squared equals 4px, except we get this negative in front. So if our graph is facing left, it should be negative instead of positive. Now, we're going to take a look at vertical parabolas. So this one here on the left side, this opens up. Once again, this distance is p. So if our vertex is 0, 0, then our focus is 0, p. And our directrix is y equals negative p. All right, we're just going out a distance of p in either direction from the focus, or from the vertex, I mean. And in this case, we get x squared equals 4py. So just like in regular old algebra, when you think of your basic quadratic function like y equals x squared, you think, well, x squared tells me, oh, it's facing up. Right, well, that's the same case here, as long as this is positive, x squared equals 4py. Now, if we change this around slightly, and we have a parabola facing down here, my distance, still p in either direction, from the vertex to the focus and from the vertex to the directrix. But since we're facing down here, the focus will be at 0, negative p, and the directrix this time is at y equals p. And the equation for this is x squared equals negative 4py. So when I think about these equations, I try to remember like a few key principles. I remember this format of the 4p times x or y, and I think that if it's x squared, I'm facing up and down. If it's y squared, I'm facing right or left. And if it's negative, I face in the negative direction. So in the case of a parabola facing right or left, the negative direction is of course left. In the case of a parabola facing up or down, the negative would be down. All right, well, with all of that in play here, let's go ahead and try to use it to determine things about a parabola given an equation. So if we have this equation that we have, x squared equals negative 2y, and here we're asked to find the focus, the directrix, given the equation, and then to graph it. So I think back, okay, well, this is something like x squared equals negative 4 py. That means this 4p is 2. So I can solve for p using that information. 2 equals 4p, and so p equals 1/2. Now, in order to find my focus and directrix, even if the directions don't explicitly say so, I'm always going to do it by graphing first. So actually, I think finding these and then graphing is kind of the opposite way to do it. I have no desire to rely on memorizing a big table. Instead, I just want to understand the geometric relation of these points to the graph. So let's go ahead and graph this thing. Well, our vertex is at 0, 0. Now, since p is 1/2, and since we're x squared, first of all, I should say, since it's x squared and this is negative, we're facing down. Now, since p is 1/2, that puts my focus down below the vertex. And of course, that point would be 0, negative 1/2. Similarly, my directrix is going to be a distance of 1/2 above my graph, above my vertex, and that makes the directrix y equals 1/2. So our directrix is y equals 1/2. Our focus is the point 0, negative 1/2. And we've already graphed the equation in the process. So I think it's much easier to keep this thought process in mind when trying to work out parabolic equations, their properties, and their graphs. It's much easier to think about the geometry here and understand that than it is to try to memorize a whole bunch of different stuff on a table. Okay, so let's take a look here. Here we're given a graph. We want to find an equation of the parabola whose graph is shown. So here our vertex is clearly at 0, 0, and our focus is at -3, 0. So that means my distance p here is 3. And remember, p is a distance, so it's always positive. But our equation, because we're facing left, is going to have the form y squared equals -4px. Well, that tells me that if p is equal to 3, that y squared here is -4 times 3 times x, which is, of course, just -12x. And that's it. We have found our equation. All right, well, that's it for part 1. I hope this is helpful.